to a complex number problem. This is 3. Okay, I saw Euler form already, which I'm very happy. So complex numbers z1, z2, z3, you have non-Euler form and Euler form all together lah. So z3 is, z1 is what? 3 minus I square root 3. Z2 is what? Okay, 1 over EI 2 pi over 5. Okay lah, this is very simple. 3 is what? Z1 times Z2. Okay, nothing much. Find the exact modulus and the argument of Z3. That means that we have to manipulate this. You can use calculator to punch. Nothing much. 2 pi over 5 is what? 2 pi over 5 is or you can try to do something at Z1. This is 3 marks problem. Z1 equals to 3 over square root. I mean that 3 and square root 3. So what is your first impression on this thing? Can it be, can we do in Euler form? Because it looks easier in the Euler form, right? So what is the modulus here? The modulus of this thing is equals to 3 square plus 3, correct? Which is equals to 12. Modulus square. Okay. Are there any benefits of doing this? Yeah, there is. So what you can do is that Z1 is equals to, you use the 2, you put a square root 3 here, then it become square root 3 over 2 plus I 1 over 2. You look at this thing, isn't that this is cosine by I sine? Even that this can be cosine theta pi over 3 pi over 2, and for sine theta it is a negative number 1 over 2, so it probably be at the third quadrant or the fourth quadrant, which is a minus angle. So minus 6 1 over 6. So this can be pi over 6 minus pi over 6. So this is, you need to be familiar with the trigonometry angles. 60 degree. Okay, so this cosine theta equals to square root of 3 over 2, then is equals to cosine is pi over 6, but cosine minus pi minus theta is cosine theta. It's an even function. So Z1 become 2 square root 3 E minus pi over 6I. Got it? So because this is a minus here, so theta, sine theta is minus pi over 6, the angle. So now I got in Euler form already, which I'm very happy. So Z3 equals Z1 times Z2, so which is also equals to 2 square root 3 times, just now Z2 is what? 1 over 2, right? Okay, and then the angle is minus pi over 6I, and then plus, okay, I 2 pi over 5. So we can easily manipulate this, become square root 3 E, okay, 5 and 6, so it's the 30, right? Then this is 6 times 2 times 6 is 12. 12 minus 5 is 7. Okay, so easily speaking, modulus of Z3 is square root 3, and argument of Z3 it is pi 3 7 over 30 pi. you cannot use calculator, very difficult. Oh, this is using this method is better. Alternatively, you can convert it to polar form. Okay, but I think the result will be the same. Okay. Oh, I mean you need polar form, but I think this will be easier. You just extract, factorize, or do the extractions 2 over square root 3, and then will looks very neat and steady. Okay, you need to be familiarized with the trigonometry, no matter how. So question B, now we have square root 3, then this is 7 over pi. Wow, so then you have this sketch the Argand diagram showing z1, z2, z3 Argand diagram. IY, this is z, right? Okay, so you have minus. Okay, you just plot the things I mean, you can use your calculator to plot it. This is 3 unit here from z1, then z2 is what? Half over 2 pi 5. 2 pi 5 is the first quadrant things. Pi, half pi, just draw a circles here. Very small tiny little dot here. This is z2. z3 is what? Smaller. So this is somewhere around here. z3, I use blue line to draw. z3. Okay, so you can just plot it, whatever you like, then give you 2 marks already. Okay, so remember this angle is 7 pi over 3, 30. This red angle is what? 2 pi over 5. And this no angle, just draw it like that. Okay, then what do they want in question C? Question C looks more difficult. I think you still C. They say that z3n is purely imaginary. That means that the cosine term, it is 0. So how to make the cosine term 0, then you know. So we need to know the De Moivre theorem. But actually, when you use Euler form, De Moivre or not De Moivre, square root 3 e I pi 30 times 7, right? So which means that square root 3n is e n 7 pi 30 I. So which means that in order for cosine theta to be 0, the theta have to be 2n pi plus and minus pi over 2, correct? Or 2j pi plus and minus 0.2 In this case, the modulus when k is an integer, find the smallest possible values of n for which that this is purely imaginative. So which means that the smallest possible values, probably j is become 0 and theta is pi over 2. So pi over 2, that become 7 and pi over 30. But n is an integer, right? You say that? Yeah, it's an integer. So this cannot be an integer here. So you must have 2 pi here. So how to make it 7? Divided by 7. Okay, you try You try 4 plus 1, 5 cannot. Then 3 plus 1 can, right? So when j also cannot, is 2 and pi plus and minus pi over 2. So cannot. 6, 2 times 1, 2, 2, 4 cannot. 3, 2, 6, 6 plus 2, 6 plus 1, 2, 2, 6, 2, 2, 4, 4 plus 1, 5 cannot. Okay, 3, 3, 2, 6， 6加上6派啊，6乘2 12加1不可以。8乘2 16不可以。9乘2 9 2 18没有9哈，10 12 2110啦。So you see when J this is cannot lah. So but when J is 10, this become 20. Okay, J is 5, sorry. J is 5 so this become 5 times 2 times 2 20嘛 plus 1 pi equals to 7 times 30 n pi, correct? So then it divided by 2 lah, definitely. So then this is 7, this is 21, so it's 3, 15. So your n become what? 15 times 3, 45. So n is 45 is a minimum number that it can become purely imaginative imaginary, okay, not imaginative, imaginary. So then they ask you, in this case, give the modulus in the form of this and this. Okay lah, this is very simple. This is n is what? 45 and 45, then my square root 3 is 45 45 become what? 3 to power of 22, right? Times 3 to power of half. Correct. And k become 3 to power 22. That's it. Answer correct or not? Should be correct. Oh, n is 15 now. Why is 15 now? To be purely imaginative, 2n pi plus and minus pi over 2 okay lah. My one is more accurate lah. You use my answer better lah. Don't use the 10-year series answer. I wrong one. Okay. So this is the one. You imagine that you theta plus and minus pi over 2. This is very important. Cosine equals 0 is 2n pi plus and minus pi over 2. Or it's not. What, 2k plus 1 pi over 2. No, it's not like that. Okay. Cosine theta, this is the general solutions of cosine theta. Okay, use my interpretation which is more correct.